Hello, welcome to the first video of the series. This video is an easy introduction to LangChain with the use of OpenAI models. We get started right away. In this video, we want to ask questions about Hugging Face path models, hence we want to use the knowledge from this lovely web page and another web page as a part of the Hugging Face documentation. So how do we do this? As I mentioned briefly in the introduction video, we have 5 steps: data prep, embed, persist, query, and prompt. We are going to use the LangChain framework for all these steps. If you haven't used this framework before, then no worries absolutely. We will go step by step. Then first step comes, here is the data prep step. For the data prep, let's jump onto the code. I put these two markdown files from Hugging Face and placed them under this directory. Here it is, the other markdown. In order to use them, we have to read these files first into our Python script. For all of sort of this work, we work with some documents, so LangChain offers a bunch of classes and methods to read and manipulate documents into your Python script. Here comes the directory loader class and its method .load, which will return the content of the R2 markdown files as Python strings. So after we invoke this function here, documents are just strings. Next, we need to chunk the documents. All statistical models, transformers, LLMs, all kinds you can think of has fixed context sizes, so you can fit only a limited length of text. So we need to divide long documents into shorter chunks of the text. Here is also one benefit. If you have a specific question, most probably answer of your question lies within a paragraph. So you need to fetch that paragraph or couple of paragraphs, not all of the text. So chunking the text will also give us the advantage of processing smaller chunk of text. So this piece of code will do this business. This class, recursive character text splitter, accepts these parameters: a chunk size, character count, 500 here. Overlap is going to slide a window over the text, and chunks will overlap by 100 characters. Here you want to do something positive and usually like 20% of your text length, because you do not just want to corrupt the text at some random points, but rather you want to give some previous context, edit, so everything goes smoothly. We add the start index to the each chunk in the document to locate our chunk. After the retrieval, we will see it. Then we create our chunks as a list of text, each length 500 characters. Okay, now we again jump onto the code. So I put those code into database making code. We have other code, but for now, please focus on only the document making. So here are our two imports. One is from document loaders. As we mentioned, there are quite many loader types. And here is the text splitter. And here is our code. So let's invoke this one and see what happens. So this two code is going to be invoked here in another thingy, which will actually save the database, but discard it for now. Let's focus on the document preparation only. Okay, so we put a print here, just like here, how many chunks came from this document. Here we got 2 documents and 36 chunks at total. We also wanted to print out a random chunk, the 10th chunk. First, we print the page content. It's here, and we also print out some metadata. It is also here that from which document exactly this chunk come from, and also the start index of this chunk in the document. Great, perfect. I hope it looks good until now because we finished prepping the data. Now we are going to embed the data. If you haven't worked with embeddings before, basically embeddings are representation of text as a single vector which contains semantics of the text. Here you see an illustration of word embeddings. Each word has a dense vector. Those vectors carry quite many semantics such as gender, plurality, part of speech, and much more. By the way, I took the illustration from JLMR blog, a great blog and a great guy. I promise I left a link below if you wanna visit the blog. So, vectorizing a text is called to embed frequently. There are quite many ways to create embeddings. Word vectors like here. A recent development of NLP is called sentence encoders, hence sentence embeddings, where you can embed your sentence or your paragraphs as a huge chunk of text into a single vector. Here we are going to use embeddings from OpenAI. You will give your text to this embedding and it will return you a vector, just like here. Let's go back to the code. I made a play script, just like here. I will clean my screen. And then I'm going to invoke this one, embeddings play, and see what happens. Here are the imports. Here is the importing the AI embedding from LangChain OpenAI. There is a second thingy. We will come to that in a minute. So let's embed with our brand new model, Angelina. Its vector is of length this. When you have embeddings, you can ask for semantic similarity between two texts by comparing those vectors, just like here. Let's calculate distance of Angelina to Jolie and Angelina to Pete. Angelina Jolie was Angelina Jolie Pete for some time, so Pete should have a small distance, but still bigger than Jolie, just like here. Now, we collected all the documents and we can turn them into vectors. So we will place vectors of our chunks into the vector database. So we go back to make database here. We make these parts already. Now comes the database making part. Here comes the persist part. Here, for this part, we use ChromaDB as a vector database. Here is how we do, just like here. We create a Chroma instance from our chunks, and then we tell where to persist it. Here it is. We invoked this code already, so we see this one already here. And then we need to also feed the embedding function so that the vector base knows how to embed the documents. Putting all together, here is the code. Load all of the documents, split them into chunks, and then persist them into the vector base. Perfect. We created our database. Now we can throw our query safely. Here is how the query happens. On the query time, we would like to restore the database that we persisted. Note that the embedding function should be the same or everything just messes up. Then we ask our database the most similar chunks to our query string. Here the database vectorizes the query and compare them to vectors of stored chunks. Here in this video, of course, we have small number of chunks, only 36, but in real applications, there can be quite a lot of number of chunks, such as millions. Vector databases implement efficient semantic search algorithms for this purpose. So let's see the code. Here comes the code. In another script, which is Go query, I go clean my screen again. So we pass our query from command line with the argument parser, and then the database is gonna fetch all the relevant chunks. So here is the code you saw a minute ago, and this is the all context, which is the fetch context. So let me just run this script for you. Here it is. So this is our query, which is exactly written in our chunks that how to make a path model from the config. Here we go. Here is the fetch context. Something small, but now something long, which is actually something very good indeed. And these are the sources the top 3 come from because we ask for top 3 relevant documents. We join all these chunks as all contexts here and create our prompt like this. So this is our prompt template. From this template, now we are going to form our real prompt with the help of another LangChain class, chat prompt template, by just substituting context to the context and question to the query. Here is the final prompt that we make. So we augmented the prompt with some context we have. We fetch the context. Now we go ahead and feed our augmented prompt to the OpenAI model here by model.invoked our prompt. And then get the response. This is the response from LLM. Here it is. Here it is. And then also some metadata. That's it really. We prep the data, we embed the documents and persist to the database through our query, augment, and prompt. Easy peasy. As you see, LangChain as a framework offers everything you need to make the code. All you need is to just navigate yourself into some offered methods and classes. In the next video, we do not use OpenAI, but we are going to use local models. In the next video, we do not use OpenAI, but we are going to use local models, which are totally open source. If you want to learn about how to do that code with local embeddings and local LLMs, please jump on to the next video. Until now, bye-bye and see you in the next video.